inverse operations to solve equations with variables on both sides. Think about this question during the lesson. Jonah and Lizzie are both making smoothies. Their smoothies will have the same number of fluid ounces. Jonah uses 6 ounces of juice, and Lizzie uses 12 ounces. Jonah uses 4 containers of yogurt to make his smoothie. Lizzie uses 2 1/2 containers of yogurt to make her smoothie. How many ounces of yogurt, X, are in each container? One way we can solve this problem is to draw a bar diagram that represents the situation. Then, we can use it to solve for X. The top bar will represent Jonah's smoothie, and the bottom bar will represent Lizzie's. The darker part of each bar represents the amount of yogurt, 4X for Jonah and 2 1/2 X for Lizzie. The lighter part of each bar represents the amount of juice each of them used, 6 ounces of juice for Jonah and 12 ounces for Lizzie. We need to divide the bars to compare the two smoothies. Watch this. The first column represents 2 1/2 X for both of them. The third column represents 6 ounces of juice for both of them. The second column represents the remaining part of each smoothie. For Jonah, that's 1 1/2 X ounces of yogurt. For Lizzie, it's the other 6 ounces of her juice. Look more closely at the second column. You can think of 1 1/2 X as 3 copies of 1/2 X. And we can also break Lizzie's bar into 3 equal sections of 2 ounces each. So 1/2 of X is 2 ounces. What's X? The diagram shows that X is equal to 4 ounces. Another way to solve this problem is to write an equation, and then use inverse operations to solve for X. How does the bar diagram help us set up the equation? The bar diagram helps show the relationship between the quantities. 4X plus 6 is equal to 2 1/2 X plus 12. Subtract 2 1/2 X from both sides of the equation. Why should we subtract 2 1/2 X from both sides? We subtract 2 1/2 X from both sides to get the variable terms on one side of the equation. Notice that, since 4 is greater than 2 1/2, it makes sense to subtract 2 1/2 X from both sides. Now, we have only one variable term, and it has a positive coefficient. Subtract 6 from both sides to get all of the constant terms on one side of the equation. Again, we have only one constant term left. Here's an equation that we definitely know how to solve. If you rewrite 1 1/2 as 3 halves, then you can multiply both sides by the multiplicative inverse, 2/3. So, this method also shows that X is equal to 4. That means there are 4 ounces of yogurt in each container. Now you can solve equations when there are variable terms on both sides.
Class A was given a sunflower with a height of 8 centimeters that grows at a rate of 3 1/2 centimeters per week. Class B was given a sunflower with a height of 10 centimeters that grows at a rate of 3 1/4 centimeters per week. After how many weeks are the sunflowers the same height?
Now, we are looking at this equation with 2 variables now. So let's let W equal the number of weeks. So they tell us what variable to use, and they've done that for us, and we're filling in the blanks. So let's identify important information here. Class A is given a sunflower with a height of 8 centimeters. It grows at a rate of 3 1/2 centimeters per week. And then Class B is given a sunflower with a height of 10 centimeters that grows at a rate of 3 1/4 centimeters per week. Question is, after how many weeks are the sunflowers the same height? So we start by filling in our equation that they provided for us. So we don't know the number of weeks, so that's why we have the W. But we know the rate that they grow for, let's say, class A is 3.5 centimeters. So I'm going to write 3.5 as a decimal. So I'm going to do 3.5 is the same as 3.5. So 3.5 times W plus 8 will equal, on the other side of that is class B, and how many centimeters it grows at the rate of 3 1/4. So 3 1/4 as a decimal is 3 25/100. So let's go back. We have 3 5/10, which represents 3.5 centimeters per week for the class A, plus the 8 centimeters it grows each of those weeks. And then on the other side of the equation, we have the 3 1/4 for class B, that it grows each week. And the 3 1/4 is as a decimal 3.25, and plus 10 centimeters that it grows for each week. And so now we have to move some things around in this equation. So we're going to move to the left of the equation the term that has a W. We want to move that over to the left here. So the inverse operation of multiplication would be division. So we're going to subtract, because we're not multiplying here. We're going to subtract the $3 and 25/100 centimeters on both sides of the equation. And this will cancel out over on that side, so we're left with just the 10. And then on this side of the equation, we have the 3 5/10 minus 3 25/100. And that's going to be negative, let me double check my math, negative 0 and 25/100. Okay. And so now we've moved over the term 3 and 25/100 over to the left of the equation. And now we have negative 0 and 25/100 times W plus 8 equals 10. Now we're going to move, and I'm just going to do a different color. Now we're going to move the 8, which is another term, and we're going to move it over to the right of the equation. So now our numbers, all numbers, are on the right side. So we're going to subtract 8 on both sides of the equation. That cancels out, so we're left with 0 and 25/100. It's negative. And then we have 10 minus 8, which is going to be 2. So we have negative 0 25/100 times W is equal to 2. Now we want to solve for W. We want to know how many weeks this is. So the final step is to now do the inverse of multiplication, which is division. And we're going to divide this negative 0 and 25/100 on both sides of the equation. And we get 8. So the amount of time that both Class A and Class B flowers will be at the same height will be during week 8. So that is how we have taken an equation with variables on both sides and solved for that variable.
Teresa earns a weekly salary of $925 and a 5% commission on her total sales. Ramon earns a weekly salary of $1,250 and a 3% commission on sales. What amount of sales, X, will result in each of them earning the same amount for the week?
Use a bar diagram to write an equation. So here's our bar diagram written for us. We have, bring this down. we have the 0 and 5/10 times x. That represents the 5% commission. And then we have 925 on the other side. So this is for Teresa. Then we have the second bar diagram right underneath, and it has 0.300 times x, which represents 3% for Ramon. And this is how much Ramon earns in that week. Now we're going to write an equation based on these bar diagrams. And so we're going to solve for x. So we took the first equation for, what's her name? For Teresa. And then the second equation for Ramon. And so we're going to solve this equation with variables on both sides. So we have this equation here, and the next step will be to bring over the term with the x. In this case, they're bringing it over to the left side of the equation. So 0 and 3/10 is being brought over here. And as you can see, they subtracted it from both sides. So now we're left with 0 and 2/10 because 0.05 and 0.03 equals 0.02x plus 925 equals 1,250. Then we take the 925, we're going to bring it over to this side of the equation. So we're going to do the inverse of addition, which is subtraction. And so that's being subtracted on both sides. And then we have 0 and 2/10 times x equals 325. Then we're going to solve finally for x, and we're going to divide, which is the inverse of multiplication, divide by that 0 and 2/100 on both sides. And so x is, which is the amount of sales, is $16,250 of sales for both Teresa and Ramon to earn the same amount.
Kelsey withdraws $25 per week from her bank account. Each week, Chris deposits $15 of his allowance and $20 earned from dog walking each week into his bank account. After how many weeks will they have the same amount of money in the bank?
So we have this bank statement, and it shows all this good information that we're going to use. And so the equation we're going to write is going to include x because that's going to be our weeks that they are earning money. So Kelsey earns or withdraws $25 per week. So we have $550 because based on her statement, this is Kelsey's, she started with $550. And then we're subtracting the $25 she earned every week, or she's withdrawing every week. We're subtracting it, and then we're multiplying it by x, which is the number of weeks, which we're going to solve for. Then for Chris, he started with $10, and he is depositing, which means he's putting into the bank, $15. So each week he's depositing $15, and he's depositing $20. So we are adding 15 times a certain number of weeks plus $20 times a certain number of weeks. So now we're going to combine like terms. So we have 15x and 20x equals 35x on this side of the equation. This side of the equation stays the same because there are no like terms on this side. Then we have 25x minus 25x and 35x, and we're going to move one of them to the opposite side of the equation. So we're going to take the negative 25x and move it over to the other side. And the inverse of subtraction is addition. So they've added the 25x on both sides. And now we have 60x plus 10 on this side, and then 550 alone here. Then we're going to take the 10 and we're going to move it over to the other side with the other number. And so the opposite of positive 10 is minus 10. So we're going to subtract 10 on both sides, and we're going to get 540, and we're left with 60 times x on the other side. Now the final step is solving for that x. And so we're going to do the inverse of multiplication, which is division. So we're dividing by 60 on both sides of the equation, and that equals 9. So after 9 weeks, that is when Kelsey and Crystal have the same amount of money in their bank. Solve the equation 96 minus 4 and 5/10 times y minus 3 and 2/10 y is equal to 5 and 6/10 times y plus $42.80. So I said money, but that wasn't necessarily what it was. Let's go ahead and solve. All right, so the first step is to see if you have any like terms. So on this side of the equation, we do have like terms. We have minus 4.5y and minus 3.2y. So I'm going to combine those together. They both have a minus in front of them, so we're going to add them together. So 4.5 and 3.2 is going to be, I'm going to rewrite this equation. So it's now minus 7 and 7/10 times y is equal to 5 and 6/10 y plus $42 or 42.80. Now, we need to decide whether we're going to move our terms with the variable to which side or our terms with the numbers to the other side. So I am going to move the minus 7 and 7/10 y to the right side of the equation. So the opposite of subtraction is addition. So I have 7 and 7/10 I'm going to add on both sides of my equation. So it's going to cancel out on this side. I'm left with 96. And then I'm going to add the 7 and 7/10 plus 5 and 6/10. That is 13 and 3/10 times y plus 42.80. Now I'm going to move my 42.80 to the other side, the left side. So I'm going to do the opposite of addition, which is subtraction. And I'm going to subtract this on both sides of the equation. This cancels out. I'm left with 13 and 3/10 y on the right side. And then I have 96 minus 42 and 8/10 on this side. That equals 53 and 2/10. Now the final step is solving for y. So now I'm going to do the inverse or opposite of multiplication, which is division. So I'm going to divide the 13 and 3/10 on both sides of my equation. And that's going to tell me what y equals. So 53.2 divided by 13 and 3/10 is equal to 4. So the value of y in this equation is equal to 4.